Okay, here's our second example. Difference here is we've got a negative cosine value, but we're still dealing with the same domain. Okay, so let's write it out. Cosine x equals negative root 2 on 2. First thing, two things I identify are my basic angle and my quadrants. Now when you get your basic angle, the negative's not relevant, okay? The negative's relevant for the quadrants that I'm in. Alright, so I'm worried about root 2 on 2 there. I look up my table. Okay, which angle has a cosine value of root 2 on 2? Malachy is quite correct. The basic angle, and we can start writing BA equals pi on 4. Okay, now I worry about the negative. Cosine is negative, abbreviation there, in what quadrants? Where is cosine negative? Second and third quadrants. So I'm dealing with second and third quadrant. So just to quickly go back up to my little rules there. Come back to that in a sec. So because I'm dealing with second and third quadrant, my answers will be pi minus the basic angle and pi plus the basic angle. Back to here. So x equals pi plus pi on 4 and pi minus pi on 4. Did the wrong way around, doesn't matter. Should have done the other way around. But we'll get the same two answers. So second quadrant, third quadrant. There we are. So x equals, what's pi plus pi on 4? 5 pi on 4. Remembering pi is 4 pi on 4. And pi minus pi on 4 is 3 pi on 4. There's my two answers to that trig equation. Identify basic angle from reading off the table. Identifying what quadrants I'm dealing with. And then adding and subtracting based on the little rules up the top. You don't even have to look at those rules after a while, you just remember them. So there we are. Any questions about the second example, Matthew?
Pi be one as well.
Okay, is cos pi negative root 2 on 2?
Oh, yeah.
Not, is it? Okay, you can always check. Well, if you've got a calculator, you can't check. But yeah, well, you can check wrong answers. Okay? All right. Okay, just going up a slight, I'm using degrees here, so I thought I'd throw that in, just in case there's one in the exam on degrees. And there's another little twist, okay? Or two couple little twists. Right, some extra elements here, all right? So, first thing is, tell me a couple of things, well, other than the degrees instead of the radians, what are two other differences in the question there? Alice?
There's a 2 before the theta.
Yep.
And a 2 before the sine.
Yeah, okay. So they're the two little wild cards there, that 2 and that 2. Let's just deal with the first, I'll write the question out. And way to deal with the 2, well, how do you think I deal with the 2 out the front? What's something we could do that? Divided by 2. So sine 2 theta equals negative root 3 on 2. So that's dealt with. That's cool. But 2 theta is a bit of an interesting situation. All right? So here's how you handle that. The domain here is between 0 and 360. So when I'm working this out, and it won't be apparent to the very end of this sum as to why, so let me leave it till then. But what I do here is I make an adjustment for the 2 theta. So what I do is I double the two ends. So double 0 is 0, double 360 is 720. So my domain for the moment, I extend out, okay? See if you can see y at the end. I'm extending out my domain. So I'm going to find solutions between 0 and 720. Come back to that in a sec. Let's have a look at the basic angle though. Remember, we don't worry about the negative for the basic angle. What's the basic angle? An angle that has a sine of root 3 on 2. Maliki?
Pi on 3.
Pi on 3 is my basic angle. Now, I've got negative root 3 on 2, so I have to identify what quadrant sine is negative in. What quadrants is sine negative in? 3 and 4. Alright, now here's the trickier bit. Alright? So, 2 theta equals, okay, in third quadrant, now I'm doing the degrees here, so it's pi or 180, so it's going to be 100, I'm actually going to use, I might use radians, guys, sorry, because I've got, yeah. So just put in brackets, just so we can keep on going. Just put in brackets there, 2 pi. And just put in brackets there 4 pi. Otherwise we're going to get, so I've switched back to radians totally here, all right? So 2 theta is going to be, third quadrant is pi plus pi on 3. Fourth quadrant is 2 pi minus pi on 3. Right, now, we extended our domain out to 4 pi, and you'll see why in a second. I doubled the domain. Why did I double it? Because I'm dealing with 2 theta instead of theta. So what I've got there is the first rotation solutions, okay? Third and fourth quadrant. But because I'm now out to 4 pi, I've got to go around again. So I'll have another 2 solutions. Okay, it'll be 2 pi plus pi on 3 and 2 pi plus 2 pi minus pi on 3. So I've got my first revolution solutions.
Yeah, wouldn't it be 3 pi?
3 pi.
Yes.
Yeah. What did I do wrong there? Yes, sorry. Third solution is incorrect. It's a mistake. Thank you. 2 pi plus pi on 3, yeah. Yeah. So if you look at that, what I've done is I've added 2 pi to those first 2 solutions. So those 2 there are the first revolution. Okay. First revolution. Okay, and then we're going around a second time. Why? Because we're going to get round to solutions between 0 and 4 pi. 2 pi, 4 pi. So how do I handle that? I just add 2 pi to my first 2 solutions. Now, as Lachlan said there, it might be easier just to put 3 pi there, but I've set it out fully so you can see what's going on. All right, so here we go. Pi plus pi on 3, 4 pi on 3. 2 pi minus pi on 3. Now 2 pi is 6 pi on 3. 6 minus 1 is 5 pi on 3. Now the shortcut when you're working these out is just to add 6 pi on 3 to both of those. Because remember, we're just adding 2 pi to both of those solutions. So that's 6 pi on 3. So this will be 10 pi on 3. And 11 pi on 3. There we go. Lost the duster for this, which is annoying me.
It's on the underside
Can you see it?
of the
Oh, it's
board.
actually, yeah, it's connected
Where is
to
it?
the board.
Oh, it is too. It's hiding. That's good. Okay, so I've run out of room here a bit. So I'm just going to write that line out again. I haven't done anything different. It's just that line to get a bit bigger so you can see it. All right. So last step, obviously, is to divide through by 2. Here's the shortcut for dividing through by 2. Okay, just times 3 by 2. So if I divide through by 2, that becomes 4 pi on 6. That becomes 5 pi on 6. That becomes 10 pi on 6. And that becomes 11 pi on 6. Okay, I've divided through by 2. Now, I said I'd come back to it. Why did I multiply the domain by, why did I double the domain? Why did I do that? What's happened at the end? Yeah, okay. So by doubling the domain, do you agree with me that all of those are between 0 and 2 pi? Yep? Okay. So what I had to do is allow for 0 to 4 pi, so that when I divided by 2 at the end, they all came back into the right domain. Okay? If I didn't do that, if I just kept it at that, I would have missed half the solutions. Because I doubled the domain to allow for the fact that at the end I had to divide by 2. And that's a good check. Always check at the end that your solutions come within the original domain, which was 0 to 2 pi. So let's go through it again. First step was easy, I just divided through by 2. Then I took, because I had 2 theta, I doubled my domain, both ends. Double 0 is 0, double 360 is 720 or 4 pi. Okay? Basic angle the same. Why was it third and fourth quadrant? Because that's a negative sign value. Okay? Third and fourth quadrant, pi plus, 2 pi minus. That's third and fourth quadrant. And then, because I was going around a second time, I added 2 pi to each solution, because it had already gone round once. Tidy those up, divide through by 2. Now, I actually just noticed I've got a final last step to be really, really accurate. What do you notice about 2 of those solutions?
They're not simplified.
They can be simplified. So really, if you just add this to your answer, I should make that 2 pi on 3, and that one there 5 pi on 3. The other 2 are fine. Okay, so just do that final cancelling. Would they take marks off? You don't leave anything to risk.
Would you go straight to that answer from adding like pi?
Yeah, you could. Yeah, good point. Yeah, so straight from there to there. That's fine. Yeah. All right. Yeah, I'll do one more example. And I'm sorry, when I tried to screen capture it, it wouldn't go down to that small. So the question here, the next question, let's go up. The next question is actually the middle bit. The middle bit here. That's the actual question.
That's exactly what I said. You missed the whole first part.
The last example before we do some of our own. Okay, here we go. Now, big light bulb moment here. Any question, any trig equation that has sine on one side and cosine on the other will become a tan question. All right? Make some note for yourself. Sine equals cos scenario will become tan. Why do you ask? Let me show you. Okay, I'm now going to divide through by cosine 3x, both sides. Remember, if I do both sides to an equation, oops, I don't need that. If I do the same thing to both sides of the equation, that's fine. There we go. Just write my domain out here. Notice how some of these questions have x and some theta. Doesn't really matter. All right. What's the right-hand side become, Kobe? What's cos 3x over cos 3x? 1?
Yeah.
Yep. Okay, what's that rule about sine over cos? Tan. So sine 3x over cos 3x becomes? Tan 3x. There we go. There we go, tan equation. There it is. So you divide both sides by cos. Alrighty. Now, next thing, we adjust the domain. Because we haven't got x, we've got 3x. In the last question, when we had 2 theta Alice, I doubled the domain. Now we've got 3x. What do you think I do? Triple it. Triple 0 is 0, or emergency. It was a bad dad joke. And triple 2 pi is 6 pi. Thanks, Tyler, you laughed. So we're tripling the domain here because it's 3x instead of x. Right, back to the basic angle. Maliki, which angle has a tan value of 1 according to the table? Pi on 4? What's your usual place there, Maliki? Okay, so pi on 4 is the basic angle. Where is tan positive? What quadrants? 1 and 3. So tan positive, first and third quadrant. Beautiful. So 3x. Okay, first quadrant's just the basic angle. Okay, which is pi on 4. Third quadrant is pi plus the basic angle. Now, because our adjusted domain is 6 pi, how many times have we got to go around? 3. So we've been round once. Second time we add 2 pi to each of those. Yes, I know there's an easier way of doing this, but I'm just setting it out. So I'm adding 2 pi to both of those. What do I add for the third rotation? Careful. 4 pi. pi plus pi on 4. Yes, I'm aware, easier, but I just want to set it out so you can see the 3 rotation thing. So, here we go. 3x equals pi on 4. What's pi plus pi on 4? 5 pi on 4. Now remember, the shortcut now is just to add 2 pi or 8 pi on 4 to both of those. So we get 8 pi on 4 plus that is 9 pi on 4 and 13 pi on 4. And the shortcut here, 4 pi is 16 pi on 4, add 16 to both of those. So it'll be 17 pi on 4 and 21 pi on 4. Okay, 6 solutions. Now, remember we tripled the domain so that now when we divide through by 3, they all come back in, but we'll check that in a minute. What's the shortcut here, Matthew?
You times all the bottom by 3.
Yep, so pi on 12, 5 pi on 12. We might do the cancelling down as we go, just a bit quicker. So 9 pi on 12 is 3 pi on 4. 13 pi on 12. 17 pi on 12. And 21 pi on 12 is 7 pi on 4, if I cancel down. If you have trouble with that, just do 2 steps, but... Okay. Are all the solutions within our domain of 0 to 2 pi? Yep, because it's 0 to 8 pi on 4. Once again, that's why we divide through by, why we times it by 3. So when we divide through by 3, they come back in. All right, there we go. There's quite a few trig equations. Okay, old Jack. Sorry? Oh, thank you. Well, Travis, you can be my checker for that. That was a 20-minute video. There we go.